Hello guys, hope the previous lesson went okay for you. Today 6.2 we are going to talk about drawing angles in what we refer to as standard position, and then we're going to find something called the reference angle for any given angle. And those are the two main goals for the day, is to sort those things out. Now before we get going, let's talk about the parts of an angle. So an angle is generally, in geometry, you call it two rays that share a vertex or share an endpoint. That endpoint is called the vertex. One ray is the initial side of the angle. The second ray is the terminal side. The point again there is the vertex. Angles have an interior and an exterior, and those are the general parts of an angle. You can get into more subtle details if you want, but not really necessary. Now, when drawing an angle on the XY axis, the coordinate plane, we draw angles very specific way. We don't just plot them down anywhere on the XY axis. In standard position, the vertex of the angle will always be at the origin, and the initial side excuse me, will always be the positive x-axis. Then the angle, if it's a positive angle, goes counterclockwise. Wow, that was weird. Counterclockwise until it hits the terminal side. So initial side, positive x-axis, to terminal side, origin is the vertex. There are negative angles that go clockwise, this direction, but still initial side here, and then terminal side there. And then the arrow on the angle points the direction that it's going. So that's how we're going to draw all angles. You're not going to have to get out a protractor and measure to the nearest degree or anything. There's going to be some just estimation going on here, but you do have to get those details right. Vertex at the origin, initial side on the positive x-axis, terminal side is wherever it ends. Wow, sorry about my little congestion in my throat. Okay, reference angle. So after you've drawn an angle in standard form, there is something called a reference angle. The reference angle is the acute angle. Remember, acute means less than 90. The acute angle from the x-axis to the terminal side of an angle. And there are 4 different scenarios where you can look at a reference angle. I'm going to change my ink to green here, and I'll do all my reference angles in green. So here, if you have an angle that's in the first quadrant and you want to connect the terminal side to the x-axis, you get the exact same angle. So the reference angle and the angle itself in the first quadrant is essentially the same thing. Oh, by the way, we need to talk about a little notation here. Often in trigonometry, an angle is referred to with a Greek letter theta. So this is a Greek letter theta, T-H-E-T-A, not F, not theta, theta with a T-H. It's just a variable, just like you use X, Y, or Z as a variable. With angles, you wouldn't use X or Y because, you know, X, Y axis so often on the XY axis that you draw these things. You could use capital A for angle, for example, and that is used a lot. You could use X if it's not on the XY axis, or maybe a capital X. That wouldn't be a big deal. But it's just so often that in all sorts of mathematical textbooks that when dealing with angles, this Greek letter is used, theta. And then for other angles, sometimes they'll move into different letters of the Greek alphabet. So here, theta, there, that's the original angle. The reference angle you could call something else, but you might call it theta prime. So you put a little prime mark on a variable, and it doesn't have to be theta, it can be any variable. You can have x and x prime. Usually when mathematicians use that notation, it's because the two variables x and x prime are related to each other, but they're technically different, so you put a prime on one of them. So I'm going to use theta prime to represent reference angle. So there. Now, reference angle doesn't necessarily have a direction per se. It's just the measurement of that angle. Now, when you're in the second quadrant, let's talk quadrants. So you know this is the first quadrant, right? And then we label this the second, third, and fourth quadrants. When you're in the second quadrant, you have an angle, maybe the angle is 110 degrees. So here's 90 degrees and it's a little bit bigger, so call that 110 or whatever. In this case, the reference angle would be right here. It's the acute angle from the x-axis to the terminal side. Notice it's the negative x-axis. So reference angle is not the same as standard position. It does not have to be the positive x-axis. It was here, right? The x-axis and the positive x-axis. But the reference angle for this scenario, we're in the second quadrant, it's that x-axis. If you try to call this the reference angle, well, that's not acute. That's bigger than 90. A reference angle is always acute. So there, how could you calculate this reference angle? Well, theta prime would be 180 degrees minus theta. That would give you theta prime here. In the third quadrant, the acute angle from the terminal side to the x-axis would be right here. So that would be theta prime, the reference angle. So you just go from the terminal side to the x-axis, not this x-axis because that's more than 90 degrees. You just go to the, I don't know, what do you call it, the closest x-axis. In this scenario, theta prime would equal theta minus 180. So almost the same as this one. Pretty similar. And I didn't really write an equation for scenario 1, but in this scenario, theta prime basically equals theta. They are the same when you're in that quadrant. And then the fourth quadrant, down here, what is the reference angle? Before I tell you, take your finger and point to the screen. What is the reference angle? If you're pointing right here, you are correct. The angle from the terminal side to the x-axis, that is theta prime, the reference angle. So a formula for this reference angle, theta prime would be 360 minus theta. Again, if theta is this big angle here. By the way, if you have an angle that goes 180 plus some more, so that'd be like this angle over here goes 180 plus a little more. This one goes 180 plus a lot more. Those are called reflex angles. Really not part of the lesson. I just thought I'd throw that out there if you like to have trivia information at your disposal. A reflex angle is one that goes more than 180. So what is your assignment going to be like? Draw an angle in standard position. So several examples of drawing an angle in standard position, and then find a reference angle with no drawing given. So here you're going to have to draw your own, but find a reference angle. Notice some of these are in radians, some are in degrees. All right, let's get at this. So number 2, and like usual, of course, I'll do the evens, you please do the odds. 165 degrees. Well, we need to know some basics. So the positive x-axis itself is 0 degrees. This is 90 degrees all the way over to here. That would be 180. If you go down to here, 180 plus 90 is 270. And then if you go all the way around to here, you're at 360. So a 360 degree angle and a 0 degree angle, in a sense, are the same thing, kind of. Not really, but they end up at the same spot. So how would you draw 165 degrees? I'm going to switch to purple. I never use purple. All right, so vertex, initial side. 165 is going to be somewhere between 90 and 180. Exactly where? I don't know. I'm just going to guess and say, oh, it's right about there. And then I go like this, and I'm done. That is my drawing. You don't have to have, come on. You don't have to put these in your drawing. I just did that for reference, just for this one example. But let's check number 2. There we go. Okay, so 165, I guess, is a little closer to 180 than I drew it. But it's good enough. If you're in the right quadrant, you have all the parts drawn, that's good enough. 345. So where's 345 going to go? Vertex here, initial side here. It's a positive angle, so it goes 90, 180, 270, not quite all the way to 360. 345 would look like that. So that's it. If you know what you're doing, it only takes a few seconds to do one of these problems, and I believe I drew it well enough. So call success on number 2 and number 4. let's look at number 6, negative 10 degrees. Okay, so vertex here, initial side there, negative 10 degrees. 10 is very small, but I have to go downward in the negative direction. Of course, all the way to here would be negative 90. I don't want to go that far. So I'm just going to make a small sliver of an angle, and I'll call that negative 10 degrees. Let's see how I did on number 6. And I think my drawing is good enough. How about number 8? Negative 280. Okay, so vertex, initial side. If I start rotating in the negative direction, it's negative 90, negative 180, negative 270, and a little bit more would take me to negative 280. I think it's going to be more like that. And I'm going to call that good enough. Oh, got to put a little arrowhead right there. And that should be it for number 8. Yep, there it is. So hopefully you're getting the idea of how this works, which way positive angles go, which way negative angles go. If you can count by 90, you will be in good shape. Now number 10 is going to be tricky. Negative 430 degrees. So vertex, initial side. If I go in the negative direction, this is negative 90, negative 180, negative 270, negative 360. If I go 90 more, that's negative 450. So negative 430 is not quite that far, right? So somewhere around here maybe. All right, so that's not just a reflex angle. It's like a snail shell. It curls around on itself. Let me look at number 10, make sure I didn't mess anything up. And there, okay, their drawing is a little bit nicer and more clear. I did, mine kind of looked too close like that, but whatever, good enough. So, okay, I'm already looking at 560. This is going to be another one of those angles that kind of curls on itself. Here we go. So, vertex at the origin, initial side, the positive x-axis, positive angle, so that's 90, 180, 270, 360. 360 plus 90 is 450. 450 plus 90 is 540. 560 is just going to be 20 degrees more. So there we go. And I kind of checked it before I started, but just out of paranoia, make sure I didn't mess it up. Yeah, so there we go. You're ending in the correct quadrant. We're in good shape. Okay, now this next one is in radians. And there's only one that you have to do in radians. How do you do radians? Well, there's 2 ways. The one way is probably impractical for most people. I don't even do it this way, and I like math, but you could do it this way. So remember, 180 degrees is pi radians. We talked about this yesterday. 90 degrees is pi over 2. This is 270 would be 3 pi over 2, so like 1.5 pi. And then a complete full circle is 2 pi. So if you can count by half of a pi, 47 over 18, how many half pies is that? I mean, if you can think that way, great. I cannot think that way. So what I do is I multiply by 180 over pi. That's right. I'm going to convert this to degrees because I have been trained to think degrees. And I know I used a calculator yesterday, but I don't think I need a calculator for this. 118 and 180 is going to reduce and just give me 10. So I'm left with 47 times 10, 470 degrees. So that I can graph. So vertex, initial side. I kind of messed that up a little bit. There we go. That's better. Okay, so it's a positive angle. So positive 90, 180, 270, 360. 360 plus 90 is 450. To get to 470, I need to go about another 20 degrees. And that is right about there. So that's what my diagram for number 14 should look like. Where am I? 14, right there. So, can you see radians, think radians, and then draw a sketch, only keeping your brain in the realm of radians? Yeah, if you can think about it in a very specific way by counting by pi over 2, I suppose. But for the masses, convert it to degrees and then just do it the same way. All right? Okay, so that's all of the standard position. So your first, 6, 7 problems that you need to do on your own. The first 7 is exactly what I did. Now we're going to find reference angle. Well, to be honest, to do a reference angle, the first thing you're going to want to do is sketch this in standard position. In fact, since I need to sketch a bunch of these things, I'm going to duplicate my little XY axis so that I can use it over and over. If you use Notability, I highly suggest this to make your homework go quicker and easier. If you're using pencil and paper, it's not a big deal. But yeah, about done there. Yeah, all done. Okay, so what's 110 degrees? Let me get to another color. Let's go with light green. Let's see how light green looks. No particular reason. So 110 degrees is going to be 90 plus a little bit more. So there's my 110 degree angle. My reference angle, oh, do you know what I want to do? Wow, you're going to think I'm just super, I don't know, indecisive. I'm going to go ahead and put this in blue. I'm going to do my reference angle in green. Hopefully I can remember to keep this up. So my reference angle is right here. So how big is that angle? My reference angle, so remember I've been calling that theta prime. It's going to be 180 minus 110, which would give me 70 degrees. So my reference angle here is 70 degrees. Why 180? Well, because a straight line is 180, and we're finding the difference between the straight line and that 110 degree angle. Let me see if I'm right for number 16. Is it? It's a lot of scrolling. There it is, 70 degrees. Next one, 290 degrees. All right, so the original angle, vertex, oh, that's too dark. I'm using that blue. Vertex initial side, 290. So 90, 180, 270, plus a little bit more. That is my 290 degree angle. My reference angle is whatever it takes to get back to the x-axis. So here, my reference angle is going to be 360 degrees minus 290 degrees, which ironically is also 70 degrees. Number 18. Yep, also 70 degrees. I feel a sneeze coming, guys. If it happens while I'm talking, I apologize in advance. All right, number 120. Switch back to blue, negative 150 degrees. So vertex, initial side. Negative 150, so this is negative 90. Negative 180 would be too much, so I'm going to stop a little early. So my angle, 150 degrees right there. My reference angle is this much that's left over. I'm calling theta prime my reference angle. That's going to be 180 degrees minus 150 degrees, which is 30 degrees. So number 20 should be 30 degrees, and it is. And just to make things go easier, my next one is going to be 75. Let's do number 22 and see if we can get 75 degrees. So how does this one work? 615 degree angle is one of those big wraparound angles, right? So, 90, 180, 270, 360, 450, 540. If I go all the way to here, that's 630, counting by 9s, so counting by 90. So I'm going to be somewhere in this quadrant right here. This is my 615 degree angle. My reference angle is going to be that much. So what the heck? If I do 650 minus 180, does that give me an acute angle right there? No. So on this type of a situation, here's what we need to do. We kind of need to go back to the original 650, and let's just subtract off one complete revolution. If we subtract off 360. Actually, I need to line it up. 5, and then borrow from here, and then that's going to be a 5, and that's going to be 2, right? 255 degrees. So, in essence, what I've done is I have I didn't want to do that. I'm subtracting off. Honestly, I've got a plan here. If I could just make it work with, oh my gosh. All right, I know what I need to do. I need to make my eraser point a little smaller. If I can subtract off my first whole revolution, that 650 degree angle is basically the same thing as a 255 degree angle. So now for theta prime, I can do 255 minus 180, and that will give me this little leftover amount there. 255 minus 180, well, again, I need to line that up. 5 minus 0 is 5. Borrow from here, make that a 15. 15 minus 8 is 7. 75 degrees is my reference angle. And, oh, actually, we checked this before I started, right? I forget. Was it supposed to be 75? Yes, it was. Excellent. So the wraparound angles, they can get a little hairy. If you subtract 360 from it, basically you're taking it from, the snail shell wraparound, whatever you call it, instead of like a complete circle plus all this extra, subtract off 360. That gets rid of that whole first complete circle, and it just leaves you with the wraparound part, which is easier to work with. All right, number 24. So how did we graph this earlier today? Earlier in the lesson? Well, we multiplied it by 180 over pi. Cancel out the pi. 18 divided by 6 is 3, so that's going to be 30. And this is 17 times 30, which is 510 degrees. Trust me, 17 times 30, 510 degrees. Now, before I go ahead and graph 510 degrees, I'm going to do the little trick that I did up here where I subtract off 360. So if I subtract one complete revolution, 510, I just know it's a big number. Subtract off 360, I'm going to get a number that's a lot easier to work with. So 510 minus 360 is, let's see, borrow, that's 11 minus 6 is 5, 150 degrees. So the angle that I'm given that I need to graph is going to be 150 degrees. So there's my vertex, here's my initial side. 150 degrees is just short of 180. Like this. So if that's 150, how big is the reference angle? Reference angle is right here. Theta prime is going to equal 180, that's the half circle, minus 150, that's this angle, for 30 degrees. So my reference angle is 30 degrees. But here's the issue. Excuse me. The problem was originally given in radians. You should give your answer in radians. My answer right here is in degrees. So I guess what I need to do is take this 30 degrees and multiply it by pi over 180 again. And I could use a calculator for this if I need to, but I don't need to. The 10s cancel. 3 goes into 18 6 times. I end up with pi over 6. I bet the answer is pi over 6 for number 24. And there it is, pi over 6. Let's cheat on this last one. The last answer is going to be pi over 3. Remember that. I'm going to jot it down. The answer should be, oh wait, that's not where I am. The answer should be pi over 3. All right, let's see if this is right. So what do I do here? Well, I'm going to multiply by 180 over pi so that I can do all my work in degrees. 3 goes into 180 60 times. Negative 11 times 60 is negative 660 degrees. So that's going to be an angle that sort of wraps around several times, or multiple, and then keeps on going. Oh, I didn't mean to do that. That's my theme to any lesson. Oh, I shouldn't have done that. Oops, oops, oops. Yeah, say that a lot. Okay, anyway, so how am I going to graph negative 660? What I think I'm going to do is I'm going to take negative 660 plus 360. Again, subtract off a complete circle. So I get 0, 0, negative 300. So now, if I graph a negative 300 degree angle, so here's negative 90, negative 180, negative 270, negative 360 would be too much. I'm going to end up right in here. That would be the same as if I had done this. Go around 360 and then 300 more to get to 660. Now my reference angle is right here. Well, let's see, if that was negative 300 degrees, which would have been the same as negative 660 degrees, if this is negative 300, how much is left over there? My theta prime is going to be 360 minus 300, which gives me a final answer of 60 degrees. But our answer has to be in radians, so I'm going to multiply by pi over 180. Again, use the calculator if you're not so great with fractions. I know I can reduce the zeros or cancel out the zeros by reducing by 10. And then 6 goes into 180 3 times. That leaves me with 1 times pi on top and then just a 3 on bottom. So there I do get my pi over 3 answer. Okay, the concept is pretty easy. For reference angle, wherever an angle is, okay, I'm just doing this quick. Wherever an angle is, go back to the x-axis and that's your reference angle. And usually it's just subtracting. Depending on what quadrant you're in, you might subtract 180, you might subtract 360. When you get into negative angles or those wraparound angles, it gets a little trickier. And when you get into radians, you have to do extra conversions. But the principle is very simple. You just get bogged down in all the various steps to do this. If you find yourself getting bogged down, have complications or issues, let me know. Reach out, contact me. I will help you as best I can. Otherwise, I hope you have success on this assignment.